So this is part 2 of talking about limits that are preparing us to understand calculus. Right now we're going to look at problems where we're going to take the limit of functions as x approaches a number. Later on, we're going to look at the limits of functions as x approaches infinity or negative infinity. But for now, we're looking at when x approaches a number. And the good news is that it is actually pretty simple to do these limit problems like this. Matter of fact, let me write down the steps that I go through to solve these kinds of limit problems. So the first step is you plug whatever number x is approaching, you go ahead and plug that number into your function. It's almost like you're doing just a function problem. And the second step is almost so straightforward, I hate to write it. And then you simply calculate what the function is. If this is not clear, just hang on a minute. When you see me do an example, you'll see very straightforward. But here's the only part that's a little tricky. Once you finish your second step and you've actually calculated the value of the function, there are 3 possible outcomes when you perform these first 2 steps. And what I'm going to do, I'm going to take each of the 3 possible outcomes one at a time and show you what it means and how it works. But the good thing is there are only 3 outcomes, and you'll see in a few minutes it's pretty straightforward and it's pretty clear to see what's going on with these 3 outcomes. So the easiest thing to do is just do an example, and I'm going to call this the first outcome, and I'll go do the example, and then when I'm done, I'll tell you what this outcome is. So here's the first problem. We want to take the limit as x approaches 1 of 3x cubed minus 4x plus 8. So if I were to state this, we want to find the value of this function as x approaches 1. That's how we like to state it when we're looking for a limit. So the way we do it is, according to my steps, you go ahead, you plug the number is 1, right, because x is approaching 1. You plug the number into f of x. So every place you have an x here, I'm going to put a 1. So 3 times 1 cubed minus 4 times 1 plus 8. So hopefully everybody sees what I'm doing. I'm simply taking whatever number x is approaching, and I'm plugging that number in for x in my function. So 1 cubed is 1, so 3 times 1 is 3, minus 4 plus 8. 3 minus 4 is negative 1. It looks like instead of rewriting this whole thing shorthand, I'll just call it f of x. So the limit, I don't need this here, don't worry about that. The limit as x approaches 1 of this function equals 7. Now this is the first outcome. And the first outcome is when you calculate your limit, it equals a number. So this is what's going to happen sometime. You're given a limit, you simply plug in for x, the number you're approaching, you do the calculation, the result is a number, and you're basically done. So the limit as x approaches 1 of this function is 7. Now just for fun, I actually made a graph of this function. Like I said, even though we're doing the math with this function, I wanted to show you how the function and graphs relate. So at the bottom of this graph, there's that function. Here's what it looks like. So let's analyze what we were determining. We want to determine the limit as x approaches 1. So here's the x-axis. Here's the y-axis. 1 is right here, x equals 1. So I go to my graph. So really, I'm trying to see what's going on right here. Now I know this is pretty obvious, but just hang with me in terms of conceptually. If I'm looking for the limit as x approaches 1, the low side, I move along the graph, and I get closer and closer to x equals 1. And from the high side, I move along the graph, and I sort of close in on the same point, x equals 1. And since the high and the low side, as I'm zeroing in, they're both approaching the same value for the function, then yeah, it makes sense. The limit of this function as x approaches 1 is 7. So that's what the math told me. And you can see from a function, it's pretty obvious, it makes sense. I'm trying to determine what the function is. I guess I could have called this f of x. Of course, f of x and y are interchangeable. So what's the function? What's the function as x approaches 1? It's 7. All right. So that's the first thing that can happen. You take the limit, and it's a number. Now let's go to a second problem. Which will be an example of the second kind of thing that can happen. So in this case, the limit as x approaches 2 of x plus 1 over x minus 2 that's what we want to determine. What's the limit of this function as x approaches 2? Well, the way you do it is, first step is you simply Every place you have an x in your function, I'm going to plug in 2 and see what happens. So I'm going to have 2 plus 1 over 2 minus 2, 3 over 0. Now hopefully you all remember that in the world of math, we can never divide by 0. It's impossible. As soon as you ever have a problem where you have a 0 in the denominator, you just stop because you're done. There's nothing you can do. Matter of fact, we would say this is a symbol for undefined. In other words, there is no answer. There's no solution. We end up with a number divided by 0, undefined, no solution. This happens sometimes. You try and calculate the limit, you plug your number in for x, and you work, and you get a number divided by 0. This will happen sometimes. Your outcome is the limit is undefined. Let's take a look at this function if you graphed it out. And I want to look at specifically on the graph as x approaches 2. So here, down here at the bottom, they always list the function. So here's what it looks like. So here's our x-axis. The function is like the y-axis. So let's go on this graph to where x equals 2, or x is approaching 2. Well, 2 is right here. So what's interesting is, if on the graph we try to approach, as x tries to get close to 2 from the high side, first thing I notice is this thing is going up, 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 and it keeps going almost straight up. We could say it goes to infinity. And then what's interesting, if I try and approach x equals 2 from the low side, it's down here, and it heads toward negative infinity. So first of all, the two sides don't approach the same number. As a matter of fact, they don't approach numbers at all. Infinity is not really a number. So this is why it becomes obvious when you look at this. Obviously, there's not going to be any limit when x is equal to 2. The high side goes to infinity, the low side goes to negative infinity. They don't go to the same thing. They don't equal numbers at all. Undefined. There is no limit. Okay, that can happen. So when you try and calculate a limit, 3 things can happen. The first is it's a number. That's nice. You're done. That's a limit. The second is it's like a fraction with a number divided by 0, undefined. There is no limit. I guess I could write it here. No limit. But there's one more outcome that happens sometimes. Once again, we'll just do an example. It'll be the easiest way to see it. How about the limit as x approaches 1, x squared minus 1 over x squared minus 3x plus 2. Now I want to emphasize, once again, these 3 are the outcomes. To get to the outcome, I do the same thing. When I want to take the limit, whatever x is approaching, I take that number, I plug it in the function for x, calculate the function, and then see what I've got. And what I'm doing is I'm describing to you the three possible outcomes. So let's determine the limit of this. Since the limit as x approaches 1, here's my function. Every place I have an x, I replace it with 1. So I'd have 1 squared minus 1 over 1 squared minus 3 times 1 plus 2. All right, pretty straightforward. To calculate limits, you simply plug in the number for x. 1 squared minus 1 is 0. 1 squared is 1, minus 3. 1 minus 3 is minus 2, minus 2 plus 2. Now this looks a little bit like the second outcome because they both have a 0 in the denominator, but they're not the same because the second one had a number in the top or a number in the numerator. This one's got a 0 again. Now 0 divided by 0 is one of those cases where we don't know really what goes on. You can't really divide 0 by 0. We don't want to say undefined. It's not a number, so what is it? Well, here's what actually happens. When you get this result, first of all, you notice the function's a fraction. When you plug in the value for x, you end up with 0 over 0. When you end up with this specific case, 0 divided by 0, what you do is you have to do some more work. Because what you do, you go back, factor top and bottom of the fraction, and try again. So I'm going to go back to my original function, and I'm going to see if I can factor the top and the bottom of the function. X squared minus 1 is actually a difference of squares. X plus 1 times x minus 1. This is a trinomial, which it's pretty simple. I'm going to do it in my head. The factors are going to be negative 2 and negative 1. So I factor the top and the bottom, and what will happen sometimes is, once I factor it, I've got 2 parentheses that are factors in the top, 2 parentheses that are factors in the bottom. If I have any identical factors, they can cancel out. And look what I have, x minus 1 in the top, x minus 1 in the bottom. So now I'm left with the limit of x plus 1 over x minus 2. So this is where factor top and the bottom, I could have put in here after you factor it, hopefully something's going to cancel. And then once you cancel, you try again. So I go back now, and every place there's an x, I put in a 1. 1 plus 1 over 1 minus 2, 2 over negative 1. So once again, initially, when I took my original function and plugged in 1 for x, I got this 0 over 0. I wasn't done, I didn't stop. What I did, then I went back and tried to factor the top and the bottom. Turns out they both factored, and it turns out some stuff canceled. So now this is my new function to look at the limit of. So when I plug in x equals to 1, instead of 0 over 0, now I got 2 over negative 1, or negative 2. So actually, if I go here to the bottom, just to make it very clear, the limit of this original function as x approaches 1 is negative 2. Now for fun, let's go look at the graph of this function to see if this makes sense. Now here's the graph of that function, and I drew on here, this is another case where we have a hole. When you were graphing this function, when x equals 1, there's actually a hole here. So the graph, once it gets to x equals 1, it jumps over it, and then it keeps on going. So it's like there's a gap here in this graph when x is 1. So for this problem, so here's the function once again that we're graphing up here. We're looking at the limit as x approaches 1. So I'm looking at really this hole here. So here's the idea. When I look at the limit, when I approach it from the high side, from the positive x, you can see the function approaches negative 2. When I approach it from the low side, as x gets closer and closer to 1, the function is negative 2. So as I approach my value of x from the high and the low, they're equaling the same function. Therefore, I can say yes, in fact, the limit of the function when x is 1 is negative 2, even though this point is not defined. There is no point there. But the limit does exist, because the limit says, I don't really care what is happening at that precise number. As a limit, all I care about is, as I approach that number, what is going on. So that's why in that problem, we did in fact determine that the limit was negative 2. So in summary, when you're given problems where you're asked to find the limit of a function when x approaches a number, it's easy to do. You just plug in the number for x, calculate your function. When you do that, 3 things can happen. The first is you get a number and you're done. The second is, if you get a number divided by 0, you're also done. Of course, the answer is there is no limit. It's undefined. But then sometimes the third outcome is when you plug the number in for x, you get 0 over 0. After that, you go back and try and factor the top and the bottom, and then hopefully cancel. So in this example, when we did that, we get a new expression here, and then you go back and you try again, and when you plug in that number for x, lo and behold, you actually do have a limit. Just for fun, let's go back to the second problem, this x plus 1 over x minus 2. Let me show you one more thing before we finish out this part. Our original problem that we did a few minutes ago, was the limit as x approaches 2, x plus 1 over x minus 2. And here was that graph. If you recall, this is the one where it's undefined. This was the second outcome. We did this right here. What I'm going to do is I'm going to change my number here. Instead of x approaching 2, I'm going to choose a couple of different numbers, and let's see what happens. In other words, same function, but what if I had limit as x approaches 3 of x plus 1 over x minus 2? All right. How do we calculate limits? You plug in the number for x and see what happens. So 3 plus 1 over 3 minus 2, 4 over 1. Okay, it looks like when x approaches 3, my limit is 4, and I'm done. Now, just for fun, let's go look at the graph and see if that makes sense. So here's two problems. X approaches 2 and x approaches 3. We already looked. When x approaches 2, x is 2 is right here. There's no limit. It's undefined. But what about when x approaches 3? That's right here. So when you come from the high side, looks like the function, of course this is 10, so this is like 4 here. 2, 4, 6, 8, 10, 4. As x approaches 3 from the high side, looks like the function's 4. As x approaches 3 from the low side, it approaches 4. So the high and the low, they're approaching the same function, and that's why the limit when x approaches 3 is 4. And when the limit when x approaches 2 is undefined. All right. So that hopefully makes sense. All right. So now I'm going to stop, and in the next video we're going to look at one sort of special kind of function that you may have problems on. That's called piecewise functions and how we determine limits. And then after that, then we're ready for limits when x approaches infinity and negative infinity, and then we should be done with limits.